For today's video, I will analyze this circuit and demonstrate exactly how the super mesh analysis works. You'll learn to apply this technique methodically to find unknown currents in difficult circuits. By the end of the tutorial, you'll have a solid understanding of super mesh concepts and practical experience applying them. This technique will be extremely useful for solving complex circuits and expanding your circuit solving abilities. When dealing with complicated circuit configurations, we often encounter situations where regular mesh analysis fails to give accurate results. This is where the super mesh analysis technique comes in handy. A super mesh technique is a technique used in circuit analysis to handle situations where standard mesh analysis runs into difficulties. It is used when there are two or more meshes in a circuit that share common branches. The supermesh analysis is a powerful tool for dealing with meshes that share common branches. These are problematic cases for basic mesh techniques. We can write KVL equations around the supermeshes by combining interconnected meshes to determine their loop currents.
As you can see, we have a figure of a circuit here. This circuit consists of two voltage sources and two current sources and several resistors. The primary objective is to determine the unknown current flowing through the 10 ohm resistor, which will help us compute the power absorbed by it. However, to achieve our goal, we must first define, analyze, and comprehend the problem's nature. Upon inspection, it is apparent that the circuit has four essential nodes, which is node A, node B, node C, and node D, and four essential meshes here: mesh 1, mesh 2, mesh 3, and mesh 4, which will come in handy as we employ a circuit analysis method. When dealing with a circuit with a current source between two initial meshes, it is most convenient to use the super mesh technique. Although other methods can be employed to solve the circuit, using the super mesh is the most time-efficient approach. To apply the super mesh technique, I will assign the direction of the current flowing through the super mesh and then use KVL to analyze it. The super mesh current will flow through the 10 ohm resistor and then through the 4 ohm resistor to the 5 ohm resistor, then to the negative terminal of the voltage source, and back to the 10 ohm resistor. You are more comfortable with using other method is not super mesh, no problem. Rest assured that we will still arrive at a similar answer, regardless of which method we choose to use.
Applying KVL at supermesh, we have 10I1 minus 4 times I4 minus I1 plus 5I times I3 minus I4 is equals to 4. Simplifying it further, we have 14I1 plus 5I3 minus 9I4 is equals to 4. Now, we mentioned earlier that the current flowing through the mesh 4 is equals to 6 ampere. So we are going to substitute this value here in this equation, so we can have this equation, which is 14I1 plus 5I3 is equals to 58. And then we are going to label it as our equation 1.
Kay naa naman tay first equation, ang atong buhaton is maghimo ta og constant equation by analyzing the current flowing through or away node B. By inspection, kabalo ko na ang I1 is I1 ug ang 5 amps current is flowing away while I3 is flowing through node B. Writing a KCL equation, we have I3 minus I1 is equals 5A. Karon naa na tay systems of two equations with two unknowns. Equation 1 is 14 I1 plus 5 I3 is equals to 58. Og ang equation 2 is negative I1 plus I3 is equals to 5. Note na ang goal nato is to solve the value of the current flowing through mesh 1 para atong magamit to compute the power absorbed by the resistor. By elimination method, akong kuhaon ang value sa current I1, IA.
Karon kay kabalo naman ta sa value sa current I1, ato na lang isolve ang power absorbed by the 10 ohms resistor.
Ting the power absorbed by the 10 ohm resistor. Itong gamiton na formula na P is equals to I squared R
To confirm my work, I'll simulate the circuit in every circuit, an application that enables you to build and simulate circuits right on your phone or tablet. It also lets you animate and understand how they work, check homework, and test your designs. Here are the results. As you can see, the simulation matches my manual calculations of current I1, confirming the correctness of the analysis. Practicing these circuit analysis techniques on examples like this really helps solidify our knowledge on analyzing circuits.